Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as Associate Professor in the Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, I would like to give the topic on the ultimate analysis. So, before starting the topic, first we see what are the contents involved in today's topic. First is nothing but what is the analysis involved in the ultimate. After that, we see what is the significance. So, these are the topics. First, we see ultimate analysis. So, this ultimate analysis involves the mainly 5 contents. First one, nothing but carbon and hydrogen. And second one, nothing but nitrogen. And third one, nothing but sulfur. And fourth one, nothing but ash content. And fifth one, nothing but oxygen content. So these are the mainly 5 contents involved in the ultimate analysis. That means in this elemental analysis of the coal, the analysis includes the percentage of the carbon, hydrogen, oxygen, sulfur and nitrogen ash content in the coal. So it is the elemental analysis of the coal. This analysis includes the percentage of the carbon, hydrogen, oxygen, sulfur, nitrogen and ash content in the coal and better quality of the coal of the carbon monoxide. That means that 2 components can be determined in the single experiment, that is nothing but carbon and hydrogen. So we see determination of the carbon and hydrogen. There is a fixed diagram. So there is an inlet for the passage of the pure dry oxygen at the bottom, and at the top of the instrument there is a sample present in a platinum boat, and the combustion tube is there. It is long tube, and the coal is heated by using the Bunsen burner, and there is a box which is maintained cuprous oxide chelates, and there is a 2 U-shaped tubes. So one is the anhydrous calcium chloride and second one is nothing but potassium hydroxide solution. Finally, it is the excess amount of the oxygen. That means about 0.2 grams of the accurately weighed coal is burnt in excess amount of the oxygen in the apparatus as shown below. And in this case, the carbon and hydrogen can be determined with the help of the combustion reactions. So, what is the combustion reactions? When carbon reacts with the oxygen to give carbon dioxide, and at the same time hydrogen reacts with the oxygen to give water vapor. That means hydrogen plus reacts with half moles of the oxygen to give water vapor. From the carbon dioxide we can determine individual carbon. From water vapor we can determine the individual hydrogen. That means the first U tube, nothing but potassium hydroxide tube and calcium chloride, the second tube absorbs the water vapor. That means this potassium hydroxide tube absorbs the carbon dioxide and the second tube absorbs the water vapor. Okay, so from the increased weights of these 2 tubes, we can determine the carbon from carbon dioxide and hydrogen from water vapor. That means increase in weights of the tubes are knocked down. So that means this is the determination of carbon hydrogen. A known mass of the carbon is taken and burned in combustion apparatus in a current of a oxygen. That means in the presence of a oxygen. That means the carbon changes to carbon dioxide and hydrogen changes to water vapor. Nothing but combustion reactions. That means the vapors of the carbon dioxide and water vapor are then passed through a potassium hydroxide and calcium chloride tubes of the known weight. That means before starting the experiment, we can note down the initial weights of the calcium chloride tube and potassium hydroxide tube. That means the CO2 is absorbed by the potassium hydroxide tube, while the water vapor, nothing but H2O, is absorbed by the calcium chloride tube. That means because of the absorption, the weight of the potassium hydroxide and calcium chloride tubes will be increases after the experiment. That means which is then measured, and 12 parts by the mass of the carbon gives the 44 parts of the mass of the carbon dioxide, and 2 parts by mass of the hydrogen gives 18 parts by the mass of the water. That means we see the combustion reactions. That means when carbon reacts with oxygen to give carbon dioxide, and that potassium hydroxide to absorb the carbon dioxide to give potassium carbonate, potassium carbonate is the byproduct of the water. And second combustion reaction, this is the first combustion reaction, and second combustion reaction nothing but hydrogen reacts with the oxygen to give water vapor, and calcium chloride tube absorbs the water vapor to get calcium chloride hydrate molecules. That means calcium chloride heptahydrate. Now you can calculate percentage of the carbon from the increased weight of the potassium hydroxide tube and percentage of the hydrogen from the increased weight of the calcium chloride tube. That means percentage of the carbon increase in weight of the potassium hydroxide tube by weight of the coal into 100. And this 12 by 44 is nothing but a multiplication factor. How you can get 12 is nothing but the atomic weight of the carbon obtained from atomic number. The carbon number is nothing but 6 and atomic weight is 12. And the molecular weight of the carbon dioxide is nothing but 44. That means the multiplication factor becomes 12 by 44. And in the case of the percentage of the hydrogen, it is absorbed by the calcium chloride tube. So we can calculate the increased weight of the calcium chloride tube, and it will be divided by weight of the coal into 100. And multiplication factor is nothing but 2 by 18. So 2 is also atomic weight of the hydrogen, which is obtained from atomic number of hydrogen. What is the atomic number? 1. And 18 is nothing but the molecular weight of the water molecule. So that's why the multiplication factor becomes 2 by 18. Okay, now see what is the significance. They directly contribute to the calorific value of the coal. That means the higher the percentage of the carbon hydrogen, better the quality of the coal and high its calorific value. That means the percentage of the carbon helps in assessing the quality of a coal. That is nothing but a rank of a coal. That means the percentage of the carbon and percentage of the hydrogen, both are directly proportional to quality of coal and calorific value of coal. So this is the significance of percentage of carbon hydrogen in ultimate analysis. Next we see nitrogen. So this is nothing but determination of the nitrogen. It is also one of the important element present in the fuels. So for the determination of a nitrogen, we use the Jaldal flask method. Jaldal flask is nothing but a round bottom shape and long neck. That means in this flask we consider organic compound including concentrated sulfuric acid and copper sulfate. This concentrated sulfuric acid can act as an oxidizing agent and copper sulfate acts as a catalyst. It is called as a Jaldal flask method, and it is heated on a Bunsen burner. And by the Bunsen burner, what happens? Distillation takes place. So from the distillation, the contents of a Jaldal flask after digestion with the sodium hydroxide. Finally, it will be condenser. Nothing but refluxation takes place. That is nothing but water inlet and water outlet for the purification process. Finally, the resultant solution should be titrated against with the standard acid. So to get the excess amount of alkali. That means 1 gram of accurately weighed powdered coal is heated with concentrated sulfuric acid in the Jaldal flask, and it is treated with excess amount of a potassium hydroxide solution. The formula is KOH. And about 1 gram of accurately weighed powdered coal is heated with concentrated sulfuric acid along with potassium sulfate acts as a catalyst in a long necked Jaldal flask. So after the solution becomes clear, it is treated with excess amount of the potassium hydroxide and the liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. That means the unused acid is then determined by the back titration with the standard sodium hydroxide solution. So from the volume of the acid used by the ammonia liberated and the percentage of the nitrogen in coal is calculated as following formula. That means percentage of the nitrogen is equal to the volume of the acid into normality of the acid multiplied by multiplication factor 1.4 and weight of the coal taken. The multiplication factor is 1.4. And the next content is nothing but sulfur. So sulfur is determined from the washings obtained from the known mass of coal used in bomb calorimeter for the determination of the calorific value. That means during this determination, sulfur is converted into sulfate. That means, for example, if you can add the barium chloride solution towards the coal sample, which is prescribed as barium sulfate. Barium chloride plus the sulfur present in coal which is converted into barium sulfate precipitate. Okay, so that means the washing are treated with barium chloride solution when barium sulfate is precipitated. That means finally the precipitate is filtered, washed and heated to get a constant weight. So the percentage of the sulfur is equal to weight of the barium sulfate obtained finally and weight of the coal sample taken in bomb calorimeter multiplied by 100. And the multiplication factor is nothing but 32 by 233. 32 by 233. That means this 32 is obtained from a atomic number of a sulfur. The atomic number of sulfur is 16 and atomic weight is 32. And 233 is the molecular weight of the barium sulfate. That's why the multiplication factor is nothing but 32 by 233. And the next content is ash. That means the residual coal taken in a crucible and then heated without a lid in a muffle furnace up to 700 plus or minus 50 degrees centigrade for half an hour. The crucible is then taken out cold first in a air and then in a desiccator and weighed. That means heating, cooling and weighing are repeated till a constant weight is obtained. That means the residue is reported as ash on percentage basis. Finally, we can get percentage of ash is equal to weight of the ash left by weight of the coal taken multiplied by 100. So, next one is oxygen. So, out of the total contents present in the ultimate analysis, first one is nothing but carbon and hydrogen. And second one is nothing but nitrogen. And third one is nothing but sulfur. And fourth one is nothing but ash. And fifth one is nothing but oxygen. So out of the total analysis nearby, we completed the 80% of the analysis. Remaining 20% is nothing but represents oxygen content. So we can deduct the 80% analysis from the cent percent directly get a 20% of the oxygen content. There is no special test taken for oxygen determination. That means it is determined indirectly by deducting the combined percentage of the carbon, hydrogen, nitrogen, sulfur, ash from the cent percentage. That means from the cent percentage, we can get a percentage of the oxygen, while that combined percentage of the carbon, hydrogen, sulfur, nitrogen, ash deducted from the 100%. Now we can see what is the significance of the ultimate analysis. The first content is nothing but carbon and hydrogen. That means greater the percentage of the carbon and hydrogen, better its in quality and calorific value. However, hydrogen is mostly associated with the volatile matter and hence it affects the use to which the coal is put. That means the carbon and hydrogen is directly proportional to quality and calorific. The percentage of carbon and hydrogen is directly proportional to quality and calorific value of coal. And the second one is nothing but nitrogen. Nitrogen has no calorific value and hence its presence in coal is undesirable. That means thus a good quality of the coal should have very little amount of the nitrogen content. And the next one is sulfur. That means sulfur, although contributes to the heating value of the coal, yet on combustion produces gases like sulfur dioxide and sulfur trioxide, which have harmful effects of corroding the equipment and also cause the atmospheric pollution. That means by the formation of acid rains. Whenever the sulfur reduces the sulfur dioxide and sulfur trioxide, what happens? It reacts with the water vapor present in the environment and it produces the sulfur trioxide and sulfur dioxide with water vapor to give sulfuric acid and sulfurous acid. Okay, sulfuric and sulfurous acid. That means sulfur is usually present to the extent of the 0.5% to 0.3% and derived from the ores like iron, pyrites, gypsum, etc. Miles along the coal. That means presence of the sulfur is highly undesirable in the coal to be used for making coke for iron industry. That means since it is transferred to the iron metal and badly affects the quality and properties of the steel. That means moreover oxides of the sulfur pollute the atmosphere and leads to the corrosion. That's why sulfur is also maintained the lower percentage. And next one, ash. Ash is a useless and non-combustible matter which reduces the calorific value. That means ash is also inversely proportional to calorific value of coal. So that means moreover, ash causes the hindrance to the flow of the air and the heat, thereby lowering the temperature, hence lower the ash content, better the quality of coal. That means the presence of ash also increases transporting, handling and storage cost. It also involves the additional cost in the ash disposal. That means the presence of the ash also causes early wear of furnace walls, burning of apparatus and feeding mechanism. And final one, nothing but oxygen. Oxygen content decreases the calorific value of the coal. That means oxygen is also inversely proportional to calorific value. Oxygen is also inversely proportional to calorific value of coal. So that means these high oxygen content coals are characterized by the high inherent moisture, low calorific value, and low cooking power. That means moreover, oxygen is a combined form with hydrogen in coal, and thus hydrogen available for combustion is lesser than the actual one. That means an increase in 1% of the oxygen content decreases the calorific value by about 1.7%, and hence oxygen is undesirable. Thus, a good quality of the coal should have lower percentage of the oxygen. Lower percentage of the oxygen. That means quality of the coal is also inversely proportional to percentage of the oxygen. Okay, so this is about the significance of the ultimate analysis involved in total contains nothing but carbon, hydrogen, and nitrogen, sulfur, oxygen, and ash contents. And this is about the automated analyzer for the total carbon and the total sulfur measurement in ultimate analysis. So this is very very advanced for the determination of carbon, hydrogen, and sulfur present in the ultimate analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.